So, okay. Yes. So, okay. Yeah. So, what we are talking about is so yesterday we have seen like what is a class, and even I said what is a object is, right? So, every data type in Python is called as a class, and instances are called as which one here? Objects, right? And I said these classes are this data types are two. One is a predefined and one more is what? User defined. So we are talking about integer data type or integer class. I said integer class is used to represent which object? Integer object. Okay. Or to allocate memory for which value? Integer value. Right. But the size of this integer is unlimited. The size of the integer is unlimited. Is a all the objects in Python are dynamic in what size. So because the memory is allocated based on what values, right? Okay, so this is what we have seen. And after that, I said in Python, how you represent integer values in four formats. That is decimal, octal, hexadecimal, and binary. And I said default representation of integer is decimal. What is a decimal integer is? An integer value with base 10 is called a decimal integer. And this integer is prefixed with plus or minus. Okay. And this integer should not start with what here? 0. And this integer is created using all the digits from 0 to 9. Right. So this is how you represent. Okay. Yes. So where I said some roll number is integer, OTP number is integer, right? And there is one more integer which is called as octal integer. An integer value with base 8 is called octal integer. And this integer is created using all the digits from 0 to 7. And this integer is prefixed with what? 0 O or 0 capital O. So these types of integers are used in assembly language and to restrict the number with a specific number of digits. Okay. Then next what I'm doing is base conversions, like how to convert, how this conversion is done. So how to convert this decimal to octal and octal to decimal, right? How? Because when you print a value, because when you print a value, is it values get printed in which format? Decimal format. Even though you are trying to define, so even though you are trying to define the value in which format? Octal. See here, when I print A1 value, what is the value of A1? 28. What is the value of A3? 55. But actually, A3 is in which format? Octal format. But when you print it, you get this value in which format? Decimal. But how this conversion is done? Okay. So, yes. Now, if you see this, so this is what you might learn in schools, right? Converting, this is converting decimal to octal. For example, there is a value. Okay, assume that you have a value called some 18. So 18 is one value. But 18 is which value? Decimal value. So what is the base of this value here? 10. Okay. Now I want to convert this value from decimal to octal. I want to convert this value from decimal to octal. So whenever you want to convert the value from one base to another. Now suppose the source is decimal and destination is what? Octal. Then divide this number with what here? 8. So 18 is it. So divide this number with what here? 8. And take all the reminders. Right? So 8. So here 8. Okay, 8. So how many times here? 2 times. And the remainder is a remainder is what? 2. Okay. Then again you are dividing. Okay. But what is the remainder you'll get here? 2. What is the remainder you'll get? 2. Okay. Because is it 2 is divisible with 8? No. So what is the remainder here? 2. So 22. What is 22 here? Octal equivalent of. What is 22 here? Octal equivalent of which one here? 18. But this octal value is prefixed with, generally you write octal value prefixed with 0 O. This octal value is prefixed with what here? 0 O. Now this is converting decimal to octal. This is converting, okay, what you are converting decimal to octal. Now if you want, you can see practically this one. Okay, suppose now you have done this. Okay, you have done this manually. You have done this manually. You have done this manually. What is the value of A here? 18. The value of A is 18 and 18 is which value? Decimal value. I want to know octal equivalent of 18. Then what I can do is I can use one function here. What is the name of the function? OCT. So octal of which one? A. What is the value of A? 18. So this 18 is converted. Now what is the octal equivalent of 18? 22. So OCT is a predefined function or not? Yes. So you don't require to do any conversion. So the conversion is done by using some predefined functions. Okay. But even you can convert like this. Now manually and automatic. Automatic means you just apply one function. And what is the name of the function you are applying? Octal. In the same way, now I want to convert octal to, I want to convert octal to decimal. Then what is the octal value here? 0 O 22. So actually value is what? 22. And what is the base of this number? 8. Now I want to convert this octal value. I want to convert this octal value to decimal value. So the base, I'm taking here base is what here? 10. So I want to convert this octal to decimal. Then what do you do it? You multiply. You multiply with what here? Base. You multiply with the base. Okay, suppose this is a value, right? Now what is the value? 22. Okay, 22. Now this is which value? Octal value. You multiply with the base. Now this value is at which position? 0. This value is at which position? 0. Now 0 O 22. What is the octal value? 22. And this value is at which position? 0. And this value is at which position? 1. So you multiply with the base to the power, right? So 8 to the power of, okay, 8 to the power of 0. What you are doing? 8 to the power of 0 into 8 to the power of 0 into what? 2. plus, okay, 8 to the power of 1, 8 to the power of 1 into what is that? 2. 8 to the power of 0 into 2 and 8 to the power of 1 into 2. So 8 to the power of 0 into 2 is nothing but what? 2. Because 8 to the power of 0 is what? 1. And 1 into 2 is a 2. And 8 to the power of 1 is what? 8. And 8 into 2 is what? 16. And 16 plus 2 is what here? 18. So here 18 is which value? Decimal value. This is actual value and this is what here? Decimal value. If you want, you can see here, for example, I'm saying b equal to 0, O, 0, O, what is that? 22. If I print b value, now b value get printed in which format? Decimal format. But how this decimal conversion is done? Like this. So you multiply with the base. You multiply with the base of the position of which one? Digit. So 8 to the power of 0. Now 8 to the power of 0 into 2 plus 8 to the power of 1 into what? 2. So 8 to the power of 0 is 1. 1 into 2 is what? 2. And 8 to the power of 1 is 8. And 8 into 2 is what? 16. And 2 plus 16 is what? 18. Now this is converting decimal to octal and octal to what? Decimal, right? So this is, I mean, this is a number system you might learn in school, right? Number system is there, right? Yes. But this conversion, you can also do it by using predefined functions. This conversion can be done by using predefined functions. So these are called base conversion functions. These are called base conversion functions here, right? Yes. This is an example here. Now any value you can take and you can try to convert it, right? So this is representation of which value? Octal value. Representation of octal value. But there is one more format in which you can represent. And what is that here? Hexadecimal integer. So an integer value with base, an integer value with base 16 is called which integer? Hexadecimal integer. An integer value with base 16. An integer value with base 16 is called hexadecimal integer. And this integer is, okay, this integer is prefixed with, okay, 0x or 0 capital X. And this integer is created using all the digits, from 0 to 9, and what is that? A to F. So that is small a to F or capital A to F. So larger values, larger values are represented in which format? Hexadecimal format. Larger values are represented in which format? Hexadecimal format. So where this hexadecimal integers are used is applications. What are the applications of hexadecimal integer? Like memory addresses. Memory addresses are represented in which format? Hexadecimal format. Okay. Unicode values are represented in which format? Hexadecimal format. Okay. Register values are represented in which format? Hexadecimal format. If the value is very large, that is represented in which format? Hexadecimal format. Okay. So memory addresses are in hexadecimal format. Unicode values are in hexadecimal format. Register values are in hexadecimal format, right? So these are the applications where hexadecimal integer is used. Okay, but this hexadecimal integer is prefixed with what? 0 small x or 0 capital X. But you can use all the digits from 0 to 9 and A to F. So it means you can use how many digits for creating this 16 digits. Because of that, you are saying it as which integer? Hexadecimal integer. Suppose now these are the digits which you can use to construct this. Okay. You can use all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 means so 10, 11, sorry. So 10, 11, 12, 13, 14. So 10, 11, 12, 13, 14. Okay, so there is a value called 15. So what is a 10 equivalent of hexadecimal value? A, and 11 is what? B, and this is C, and this is D and E, and one more is what? F. So it means to create this hexadecimal integer, you can use all the digits from 0 to 9 and A to F. Okay, 0 to 9 and A to F. So such a big values you can represent in which format? Hexadecimal format. For example, I'm writing like this, N1, N1 equal to 0x. Okay, 0x, I just write here some 2A. I said N1 equal to 0x 2A. Now this is which value? Hexadecimal value. N1 equal to 0x 2A. Now this is which value? Hexadecimal. If I say N1, what is the N1 value? 42. Because always your shell display the value in which format? Decimal format. So 42 is which value? Decimal value. If you want in hexadecimal format, you can use a function called which one? HEX. Like OCT is there for what? Octal. HEX is for hexadecimal. Now N1. So what is hexadecimal of N1 here? 0x2A. So what is this 2A? 2A is a value. Which type of value? Integer value. But this value is in which format? Hexadecimal format. For example, you see some emoji characters. Emoji characters are the part of which one? Unicode characters. Some lakhs of characters are there. But every character there is equivalent what? Decimal value. For every character there is equivalent decimal value. But how this how this unique how this for Unicode characters decimal values are represented in which format? Hexadecimal format. Because lot of characters are there. Because lot of characters are there. Now suppose if I'm writing n2 equal to 0x 0x, I'm writing ABC. Is it this is one value or not? Yes, but this is which value? Hexadecimal value. This is also value, but this value is in which format? Hexadecimal. Now, if I say N2, what is the value of N2? 2748. This is also which value? Hexadecimal value. I'm saying N3, 0x, okay, 0x. Can I write AB, ABF? Can I write ABF? Yes. So what is this here? N3 value is 2751. If I'm writing N4, N4 equal to 0x, 0x, can I use bad here? Yes. Okay, now this is values which one? 2989. So N5, can I say 0x? Okay, 0x NIT? No, because is it this characters are the part of hexadecimal? No. So immediately it is given which error? Syntax error, invalid decimal, hexadecimal, literal. Because to create hexadecimal, I should use digits from 0 to 9 and A to F. But can you use any other digits here? No. Then how this conversion is done? Okay, how this conversion is done here? Okay, how this hexadecimal to decimal is done. So let us see this. So how this conversion is done? Okay, now this conversion is done like this. Now this is converting decimal to what? Hexadecimal. Converting decimal to hexadecimal. Okay, and this is converting hexadecimal to decimal. So this is a conversion here, right? Suppose now the value is so the value is 42 is there. So 42. So 42 is which value? Decimal value. So I want to convert this decimal value to which one? Hexadecimal value. So I want to convert this to hexadecimal. Now what is the base here? 16. So divide this 42 with what? 16. Divide this 42 with the 16. Okay. So 42 is a value and divide this 42 with the 16. So how many times here? How many times here? Two times. Okay. So this is what here? 32. And what is the remainder? Sorry, two times. Okay, two times. And what is the remainder here? 10. Two times and what is the remainder? 10. Okay. So how many times again? How many times is it divisible or not divisible? Not divisible. And what is the remainder? 2. So how many remainders are there? 2. One is 2 and one more is a 10. So 2. Okay, 2. And what is the 10 equivalent of hexadecimal? A. So 2A is which value? Hexadecimal value of which one? 42. Hexadecimal of 42. Now I want to convert now hexadecimal to what? Decimal. Yeah, this one you should try to understand 42. You are dividing with what? 16. How many times? Two times. And remainder is a 10. So 16 divided with what? 2. Is it 16 is divisible with 2? No. What is the remainder? 2. So 2 and 10. So 2 and what is the next remainder? 10. What is 10 equivalent of hexadecimal? A. Now I want to convert this hexadecimal which is 0x2a into what? Decimal. How can I convert this hexadecimal to what? Decimal. For this, you have to, now this is hexadecimal. What is the base of this? 16. What is the base of this? 10. Okay, 2a. Okay, 2a. And this is at which position? 0. And this is at which position? 1. Now 16 to the power of 16 to the power of 0 into a means what? 10 plus 16 to the power of 16 to the power of 1 into what is that? 2. Okay, 16 to the power of 0 means 1. 1 into 10 is a 10 plus 16 to the power of 1 is a 16. 16 into 2 is what? 32. And what is the value? 42. So 42 is which value? Decimal value. So this is converting decimal to hexa and hexadecimal to decimal. Yeah, just try to understand this. Okay. Yes, but this is manually. But Python is provided some functions, but as a developer, you should know how these conversions are done. how these conversions take place, right? How these conversions takes place. Now this is hexadecimal integer and this is octal integer. Okay, now there is another integer is there. And what is that integer here is binary integer. So there is one more integer and that is binary integer. An integer value with base, an integer value with base 2 is called which integer? Binary integer. It is always required to know all this because I said, as a data scientist, if you are working with the data, so data means information or not? Yes. So this data might comes in integers. Assume that this data is given in integers, but they have given this integers in which format? Octal format. This integers they may give in which format? Hexadecimal format. This integers they may give in which format? Binary format. Anyway, by default, it is given in which format? Decimal. So you should recognize, suppose there is one file is given. One file is given. This is one file. Which file? Some data file is there. And within this, you have a data like this 0xa, 0xb, okay, 0xab, and 0x123a. Now, they have given the data. Which data? Numeric data. This data is in which format? Numeric only, but it is integer in which format? Hexadecimal format. Now, as a data scientist, you should understand, this data is in which format? Hexadecimal format. If you don't know it is in which format, is it possible to manipulate? No, you cannot manipulate it, right? Yes. So there is one more integer is there. What is that? Binary integer. So an integer value with base 2 is called binary integer. And this integer, okay, this integer is prefixed with 0b, 0 small b or 0 capital B. So this integer is created. Okay, this integer is created using, okay, using how many digits? Two digits. That is 0 and one more is what? 1. So this integer is created using two digits. One is 0 and one more is a 1 because binary, right? That is binary. Okay. Then what are the applications? What are the applications of binary integer where this binary integer is used? Where this binary integers is used? You use binary integers, right? Binaries, zeros and ones. Where you use binary when you are working with which one? Low level. Okay, low level, which one? Programming. And not only that, when you're manipulating bits, when you're manipulating what? Bits, or when you're working with which one? Images, or when you're working with which one? Audio, when you're working with which one? Video. So this kind of data, you work with which data here? Binary data, that is zeros and ones. Low level programming, low level programming, or you can say the same thing is low level programming, or the same thing you can say. Okay, what is it? Embedded. Okay, embedded programming or embedded applications. Embedded programming or embedded applications, right? So you are trying to use this embedded programming or embedded applications. Okay, right? So this is binary integer. But how you write this binary integer? You are writing like this. N1, suppose N1, N1 equal to 0B. I just write 101, 101. Okay. So 0B 101 means this is which value? Binary value. If I say N1, so it is displayed in which format? Decimal. Okay. Decimal format. N2 equal to 0B 1010. And if I say N2, this is in which format? Decimal format. What is the value of N2? 10. N3 equal to 0B 111 and 1. So what is the value of N3? 15. If you want in binary format, use bin. So binary of which one? N1. Binary of binary of 15. 15 is which value? Decimal value. Displayed in which format? Binary format. If I'm saying binary of 0xa, 0x may a means this is in which format? Hexadecimal. Hexadecimal equivalent of binary is what here? 10. Because 0xa is nothing but what? 10. And 10 equivalent of binary is 1010. But always your shell will display the data in which format? Decimal format. But if you want to display in any other format, you take the help of base conversion functions. So Python is provided some base conversion functions. What is that? Octal function, hexadecimal function, binary function, octal function, hexadecimal function, and one more is binary function, right? Just to see here how this conversion is done. Again, suppose this is converting decimal to what? Binary, and this is converting binary to decimal. So for example, so the value is 15. 15 is it? And 15 is which value here? Decimal value. 15 is a decimal value. Now I want to convert this decimal to which value? Binary value. So how can I convert this decimal to binary value? So divide this 15 with what? 2. So divide this 15 with the 2. And how many times here? 7. And remainder is a 1. Sorry. Remainder is 1. And 2. So how many times here? 3 times. And what is the remainder? 1. Okay, and again you are dividing it. So 2, how many times here? 1 time. And remainder is a 1. Again you are dividing 2 with a 1. Now is it 2? Can you divide 1 with a 2? No. So what is the remainder here? 1. So what is the equivalent of binary? 1, 1, 1, 1. And this is prefixed with what? 0, B. This value is prefixed with the 0b. Okay. So always binary is prefixed with 0b here. Now again I want to convert this 0b. Okay, 1 1 1 1. And what is the base of this number? 2. I want to convert this binary to what? Decimal. I want to convert this binary to decimal. Then how can I convert this binary to what here? Decimal. Okay. Yes. Now this is a binary value. And this is at which place? 0. And this is at 1. And this is 2. And this is 3. Now 2 to the power of 0. 2 to the power of 0 into 1 plus 2 to the power of 1 into 1. Okay, plus 2 to the power of 2 into 1. Okay, plus the 2 to the power of 3 into 1. Okay, now 2 to the power of 0 is nothing but 1. 1 into 1 is 1. And 2 to the power of 1 is a 2. 2 into 1 is a 2. And 2 to the power of 2 into 1 is 4. And then 8. And 8 plus 4 is a 12. and this value is what here? 15. And 15 is which value here? Decimal value. 15 is a decimal value, right? Decimal value. Now this is conversion manually. This is converting it how? Manually. Now decimal to binary and binary to decimal. So if you want to convert decimal to binary, divide this 15 with what? 2. If you want to convert binary to decimal, multiply each digit with what? 2. Now that is converting binary to decimal and decimal to binary. If you want to convert binary to octal, if you want to convert binary to octal, first you convert binary to what? Decimal, and decimal to octal. If you want to convert binary to hexadecimal, then convert binary to decimal, decimal to hexadecimal. If you want to convert hexadecimal to binary, then convert hexadecimal to decimal, decimal to binary. Hexadecimal to decimal, decimal to what? Binary. So that kind of conversion you have to use it. But Python provides some predefined functions. Python provides some predefined functions, and these are called base conversion functions. And what are these functions? 3 functions just now we have seen. One is octal, second one is what? Hexadecimal, and third one is what? Binary. So all these are in small letters: octal function, hexadecimal function, and binary function. So this function, okay, this function returns which value? Octal value of given what? Integer. So this integer you can give either in decimal, octal, or hexadecimal, or binary. Okay. And this function returns, hexadecimal integer value of input which value? Integer value. And bin function is there, and this function returns which value? Binary integer value of input integer value. For example, I want to know, suppose, see here, binary of 0xa, but 0xa is which value? Hexadecimal. And written binary value of hexa or not? Yes. Here, suppose if I'm writing binary of, okay, 0 0 this is octal value. And is it returning binary of this octal or not? Yes. But how it is doing binary of octal? First it will convert this octal to what? Decimal, and decimal to what? Binary. But not directly, right? Suppose octal is there, 0b1010. Now here I given the value in which format? Binary. And you are converting binary to what here? Octal. And what is the octal equivalent of this binary? 0 0 12. Okay, in the same way I can use hexadecimal. Okay, 0b 1111. Okay, so what is the hexadecimal of it? F. Because what is the decimal of this 1111? 15. And what is 15 equivalent of hexadecimal? F. Ring on. So these functions are called base conversion functions, and you can use this base conversion functions to convert any type of integer to what? Decimal, or octal, or hexadecimal. Okay, hexadecimal. Now 0 0 12. And what is the hexadecimal of it? 0xa. Okay, suppose if I'm saying octal of 0xa, what is the equivalent of it? 0 0 12. So these are called base conversion functions, which are used to convert the base of one value to another, right? Yes, please just try to understand this. Okay, so what we are learned here is how to represent integers in Python. How to represent integer in Python? Integer value in Python. In Python, integer value is represented in how many formats? Four formats. One is decimal, octal, hexadecimal, binary. Okay. Suppose in technical, suppose you are writing one technical exam. They ask you, N1 equal to 0 O12 plus N2 equal to 0 XA, N3 equal to N1 plus N2. Find value of N3. Then how you write this? Find the value of N3. Now, what is the value of N1? 0 or 12. What is the value of N2? 0xA. This is in which format? Octal format. This is hexadecimal. Now convert this into what? Decimal. What is the 12 equivalent of decimal? What is the 12 equivalent of decimal? This is in which format? Octal, right? 8 to the power of 0 into 2. 8 to the power. Now 10 or not? Yes. Okay. So 10 plus 10 is what? 20. What is the value of N3? 20. Just to see here. Just to see here. You have to know this can now N1 equal to 0 O 12. N2 equal to 0 X A. N3 equal to N1 plus N1 plus what? N2. What is the N3 value? 20. What is N1 value? 10. What is N2 value? 10. Because what is the decimal equivalent of 0, 0 or 12? 10. What is the decimal equivalent of 0xA? 10. What is A equivalent of decimal value? 10. What is B equivalent of decimal? 11. Okay, but here I have given 0xA is 10. What is the result here? 20. Suppose if this kind of questions are there, then you must know all these things or not. Yes, to solve this kind of questions, you should know how these values are represented and how one value will be converted to what? Another value. How one value is converted to another value, right? This is about integer representation. How many integer data types are there in Python? Only one. How many integer data types are there in Python? Only one. You don't have multiple integer data types. There is only one integer data type in what? Python. There is one more data type is there. And what is the data type? Float. Float class or what is that? Data type. There's a float class or float data type. Okay. Now, just now, I mean, in the previous class, we have discussed like you represent roll number, integer, account number. Account number is what? Integer. Account number is integer. Mobile number. Mobile number is what again? Integer. Okay, now, what else? OTP number is what again? Integer. Yes or no? So this is in which format? Integer format. Suppose balance. You'll say 45,000 dot 00. Is it this is integer or no? This is not integer. This is what here? Float. Okay, suppose assume that some grade. Suppose I just write here grade. Grade equal to 4.5. So this 4.5, is it an integer or no? It is which one? Float. So what is a float value? Is a numeric value with fractional part. What is a float here? Is a numeric value with what? Fractional part or decimal part. Okay. A numeric value is a numeric value, right? A numeric value with which part here? Fractional part or decimal part. Decimal part is called which number? Float number. Float number or float literal. Float number or float literal. To reserve memory for memory for which value? Float value. Python uses which data type? Float data type. Python uses which data type? Float data type. Because Python is dynamic or not? Yes. You don't create variables with data type, and you create by just assigning value. A numeric value with a fractional part or decimal part is called float number or float literal. To reserve memory for float value, Python uses which data type? Float data type. Float data type. Okay, just to see here. Just to see here. I'm writing some A equal to 1.25. A equal to 1.25. Type of A. A is which type here? Float type. A is which type here? Float type. Now I'm saying B equal to 1 point or anything. Some 123 point. Okay. 4, 5, 6, 7, 8, 9. If I'm saying type of B, B is which type? Float type. A value is 1.25. B value is 123.456789. 4, 5, 6, 7, 8, 9. Right? So when it comes to the float in Python, yes, in Python, float values are literals. In Python, float values or literals are represented in two formats. Okay, in Python, so in Python, float value or literal is represented in two formats. Two formats. One is called as a fixed notation. One is a fixed notation and one more is exponent notation. In how many formats you can represent this? Two formats. One is fixed format and one more is in which format? Exponential format. Fixed notation is also called as standard notation. This fixed notation is also called which notation? Standard notation. And always I said, okay, always I said the size of these data types are unlimited, right? The size of these data types are what? Unlimited. But when it comes to the float, this float data type is developed. This float data type is developed by following certain rules and regulations. But who give the rules for developing this float data type? IEEE. So float, generally float values are represented using which standards here? IEEE standards. Using IEEE standards here, any programming language, not only Python, if you are working with a C or C++, or Java or any programming language, the scientific values, float values are what? Scientific values. And the scientific values you always represented by following certain rules and regulations given by whom? IEEE. That's the reason the size of this float is restricted. What is the size of integer? Unlimited. But what is the size of float? Not unlimited. If you give larger value, it takes a value as infinite. It takes a value as what? Infinite. If you take more big value, then it takes a value as what? Infinite value. It takes a value as a infinite value. So it restricts the the size of which one? Float value. It restricts the size of the float value, but when it comes to the integer, okay, it is dynamic in what? Size. Why float value is restricted? Because these float values are developed by following which standards? IEEE standards. If you give larger value, then it takes that value as which value? Infinite value. Suppose, assume that float, right? Okay, now this value is represented in two formats, and one is in fixed notation and one more is in what? Exponential notation. It is represented in two notations. One is fixed and one more is what? Exponential. One is fixed is there and one more is a exponential, right? Yeah. Now this is what exactly the size of the float value. Yes. The size of the float value is, okay, what is the size of the float value is 64. The size of float is 64 bits or how many bytes here? 8 bytes. The maximum value accepted by float is 1.8 e to the power of 307, where the value of e is what here? 10. The maximum number of decimal places are how many? 16. And float data type is developed using rules and regulations given by which one? IEEE. Okay, IEEE. Okay. So I think you people are engineers, right? So your syllabus is created by whom? IEEE. It is an organization. It is an organization. IEEE stands for, IEEE stands for what here? IEEE stands for, yes. So there are some standards given by this IEEE, right? Okay. Yes. So instead of electrical and electronics engineering, right? Okay. So there are some rules and regulations given by this organization, and float value is always developed by following which standards here? IEEE standards. Because of that, what is the size of float here? 64 bits, or it is what? 8 bytes. The maximum value accepted by float is 1.8 e to the power of 307 is nothing but 1.8 into 10 to the power of 307. If I give more than this, then it takes this float as which value? Infinite value, right? And the maximum number of decimal places is what? 16. If we give more than 16, what will happen? It will truncate or it will round. Either it will truncate or what? Round it. Okay. So float data type is developed using the rules and regulations given by IEEE. For example, I'll write like this. For example, I'll write like this. Some n1 equal to, I'm just writing here 1.121212 like this. I'm giving so many, which one? Fractional parts. Is it more than? I've given what? More than what? 16. I've given more than 16. But if I print n1, is it printed more than 16 or only 16? Only 16. It is not displayed more than 16 because it reserves space only up to what? 16. Getting on. So if you give more than 16, what it will do? Truncate, or it will do what? Rounding. Okay. Suppose n2 equal to some 1.123456789. Okay, again 1 2 3 4 5 6 7 8 9, and again I'm saying 1 2 3 4 5 6 7 8 9. So how many decimal places I've given? 20. How many? 27 I've given, right? But if I print n2, it is taken only 1 2 3 4 5 6 7 8 9, and 1 to 8. Getting on. So total number of decimal places. Total number of decimal places are only what? 16, right? So is it rounded or not? See, after 6, there is what here? 7. But after 7, there is what? 8. Now it is rounded to the nearest or not? Yes. What is the value is taken? 8. What is the value taken? 8. So the number of decimal places are only 16. If you give more than 16, it will either do rounding or truncating. Rounding. When it will do rounding, if the value is greater than, if the value is greater than what? Or equal to 5. If it is greater than or equal to 5, so if it is greater than or equal to 5. Now, here, the next digit, what you have? 8, right? 7, 8. 7, 8 is greater than or equal to 5 or not? Yes. So 7, 8. What is the equivalent value? 8. So it will do either rounding, it will do either what? Truncation. Okay. Yes. But this float value is represented in how many formats? Two formats. One is fixed notation and one more is what? Exponential. The default representation is which notation? A fixed notation, where there is an integer and there is a fractional part. This integer and fractional part is separated with what? Dot. This integer and fractional part is separated with what? Dot. This is called which notation? Fixed notation. But when it comes to the exponential notation, this exponential notation is also called which notation here? Scientific notation, where you'll be using one special character. What is that special character you are using? E. Where you are using some special character, and what is that special character is E. Suppose I'm writing 12 E, okay, 12 E1 is nothing but 12 into e to the power of what? 1. 12 into e to the power of 1. Now this is which notation? Exponent notation. What is the value of e? 10. Now that is nothing but 12 into 10 to the power of 1. 12 into 10 to the power of 1 is what? 120. Now it's nothing but 120 point. This is nothing but 120.0. 120.0. If I'm saying N4, N4 equal to 123 e to the power of minus 1. If I'm writing 123 e to the power of minus 1 is nothing but 10 to the power of minus 1 is nothing but 123 by 10, right? What is the value? 12 point, 12 point, what is that? 3. What is the value of N4? 12.3. Suppose if I'm writing N5 equal to 123.4567 e to the power of minus 2 is nothing but 123.4567 into 10 to the power of minus 2 is nothing but 123.4567 divided by 100. What is the value of N5? 1.234567. This is in which format? Alright, this is in which format? Exponential format. If the scientific format or exponential format. Okay, in exponential format, you are using one special character in which value? Float value. What is the special character you are using? E. And what is the value of E? 10. The value of E is a 10 here. Please remember this. Okay, if the value is very large, then you represent in which format? Exponential format. All these are required. I said, data. So there is some data is given like this 1.456 123e minus 1 12.456 e minus 2. If this is a data file, in this data file, which type of data is there? Float. But it is in how many formats? Two formats. Some values are in fixed format. Some values are in which format? Exponential format. Okay. So suppose I'm writing N6 equal to, I'm writing N6 equal to 1.8. Okay. 1.8 e to the power of 30 e to the power of What is the maximum value? 30. Yes. I just write 307. 307. And if I print N6 value, what is the value of N6? 1.8 e to the power of 307. Okay. Suppose if I say N7 equal to 1.8 e to the power of 308. What is the N7 value? Infinite. So it means what is the maximum range it is accepting? 1.8 e to the power of 307. If you give more than this, by default, your Python takes that value as which value? Infinite value. So how you represent infinite values in Python? Using float. Infinite values are which values? Float values only. Infinite values are float values. These are not integers, right? Okay, these are which values? Float values, right? If you give more than that range, then what it is doing? It is trying to, yes, it is trying to take that value as which value? Infinite value, right? Yes. Now this is how you represent which values? Float values. Okay, is it this is clear? How to represent integers, how to represent float. So what is the size of float in Python? Infinite. Size of float is infinite or 8 bytes? 8 bytes. The size of float is not infinite. The size of float is how many bytes? 8 bytes. If you give more than 8 bytes, it takes that value as which value? Infinite value. What is the maximum number of decimal places? 16. What is the maximum number of value to accept? 1.8 e to the power of 307. But what is the value of e here? 10. How many formats can you represent float? Two formats. One is fixed notation and one more is exponential notation. Fixed notation is there and one more is exponent notation. Okay, right. Next is there is one more number is there. In Python, one more number is there. And what is that? Another number is another data type is complex data type. Complex data type. There is one more number is there. You use one more number here. And what is the number is complex number. Complex number. Okay. Complex number is there. Okay. So this data type, this data type is used to reserve memory for which number? Complex number. Generally, if you work with any other programming languages, you don't find a complex data type. Only which languages support complex data type? The languages which support scientific calculations. Only those languages support which data type? Complex data type. For example, Java is there. You have only integer and float. Suppose if C is there, integer and float. But you don't have a data type called which one? Complex. Suppose if I want complex data type in C, I have to build my own data type. If I want complex data type in Java, I have to build my own data type. But Python is provided predefined data type called which one? Complex. Complex data type is used to reserve memory for complex number or complex literal. Value, literal is nothing but a value which never changes, right? So this data type is used to reserve memory for complex number or complex literal. So complex number in Python, complex number in Python, complex number is represented using okay, this syntax here. Now this is a syntax which is used. You are using real plus. Now first you define which value? Real value. And second, you define which value? Imaginary value. And this real and imaginary values are separated with what? Plus. An imaginary value in Python doesn't suffix with, suffix with what? I, but it is suffixed with what here? J. Okay, suppose in mathematics, you will write like this, 1 plus 2i. You write 1 plus 2i, or you write simply what here? 2i. Now this is called which number? Complex number. This is complex number, and this is which value? Imaginary value. And 1 is which value? Real value, and 2 is a imaginary. But in Python, how you represent? 1 plus 2j. Now here 1 is a real and 2 is what? Imaginary. If I'm writing some 4j, I'm writing 4j. 4 is what here? 4 is which value? Imaginary value. What is real? 0.0. So here it is not prefix, it is not suffixed with I, but it is suffixed with what here? J. Imaginary, right? So these both the values are separated with. Now, imaginary value is suffixed with, suffix with which one? J. Not I, it is suffixed with the J, right? Yes. Just to try to understand this. This is representation of which one? Float. And this is representation of which one? All right, this is a representation of which one? Complex. Complex numbers are used when you are working with what? Quadratic equations. And when you are finding the square roots, right? So you may use which data type? Complex data type. It is a literal. Suppose C1 equal to 1 plus what? 2j. What is the value of C1? 1 plus 2j. What is the type of C1 object? Complex. What is the type of C1 object? Complex. So what will happen is your Python virtual machine, the Python virtual machine, it reserves memory for how many values here? 2 values. The Python virtual machine reserves memory for how many values here? 2 values. Now, when you write 1 plus 2j, what will happen? Now, it allocates memory for which object here? C1 object. What is the name of the object? C1. And this object is having how many values? 2 values. One is real. What is the value of real? 1.0. It is having one more variable object called imaginary. See here. C1 itself is an object, and this is having how many values? 2 values. Means 2 objects are there. Now, one is a real and one more is what? Imaginary. And imaginary value is what? 2.0. Now, can I get this real and imaginary from C1? Yes. How can I get? By using dot is for accessing. Now, from complex number, I'm accessing which value? Real value. From complex number, I'm accessing which value? Imaginary value. And what is the value of real? 1.0. What is the value of imaginary? 2.0. You can access the complete complex number, or you can access individual values by using which operator? Dot. Dot is nothing but accessing member, accessing the value of specific property. Which property value are accessing? Real. Which property value are accessing? Imaginary. Please just try to understand this. Okay, this is very simple, but it is very important because all the types of numbers you use it. All the types of numbers you use it. Okay, C1 dot real, C1 dot imaginary, C2 equal to 2j. Now, if I say C2, what is the value of C2? 2j. C2 dot real. What is real? 0.0. C2 dot imaginary is 2.0. Suppose I'll say import math, and I'm saying math dot square root of 9. 3.0. Math dot square root of minus 9. Minus 9 means it should be what? 3i. It should be 3i or not? Yes. But what will happen? Immediately it is given what? Error. Because this math module cannot find complex math, right? For that, there is one more library is there. What is that library? CMath. Now just use CMath dot square root of minus 9. What is the value? 3j. Putting on. So there is a separate module for manipulating which numbers? Complex numbers. There is a separate module is there. Separate library is there for manipulating complex numbers. Manipulating complex numbers. And what is that module here? CMath. Getting on. See, Python is very simple because lot of libraries are there. In Python, huge number of libraries are there. Okay. Suppose you want to generate one password. Getting or not? You want to generate one password. Randomly, you want to generate passwords. For example, see, if you are working with a banking application is there. Okay. Password is generated by what? Application. Okay. You don't create a password, right? Okay. Later you generate the password, but by default, when the account is created, the password is generated by what? System. And that password is sent to you and you see that password and you try to change that password to your password, right? But how can I generate the passwords? Because password is random or not? Yes, it should take some alphabets, it should take digits, and it should take some special characters. Using all this, it should generate what? Password. But how many lines of code I should write to generate the password? Hardly 5 lines of code in Python. But if you want to do the same thing in other languages, you may write maybe at least some 20 to 25 lines of code because it is providing some predefined functions. Lot of functions are there, but to use that functions, you must have the knowledge of Python first. If you don't have the knowledge of Python, can I use it? No, I cannot use that, right? Okay. So you can read these values. You can read these individual values by using two properties. One is real and one more is what? Imaginary. You can manipulate individually this by saying C1 dot real, by saying C1 dot imaginary, then C2, sorry, C2, okay, and you can access C2 dot real and C2 dot what is that? Imaginary, right? Yes. So in Python, how many types of numbers you are using? 3 types. One is a integer number, second one is float number, and third one is complex number. In mathematics also, you'll use how many types of numbers? 3 types only. Integer number, float number, and complex number. Same thing. You may think that it is something else, but you have learned already from standard 1 onwards, school. But here you are learning again what is 1.5, 2.5. But already we did this. But you think that array, what is this 1.5 is? 1.5 we done long back. But you are learning again. 1 plus 2i is a complex number. We learn again. Yes or no? Natural numbers, odd numbers, even numbers, whole numbers. All these are which numbers? Integer numbers. Again, I should tell, right? But all these are we have learned long back. But even though if I say integer, question mark. Okay, yes. But already done all these things, but you are just implementing it while developing which one? Applications, right? Okay, then these are 3 numeric data types. And next one is there is one more data type is there which doesn't represent anything, right? Doesn't represent anything. And that is called which type? None type is there. None type means no value. How to create an object without value? How to create object without value? By assigning none. Okay. So none type is used to represent which values? None values. None means no value. Getting or not? See, suppose I'm representing data of student. Student data I'm representing. Student roll number, I know it. Student name, I know it. Course, I know it, but I don't know what fees. What is the value of fees? I cannot say zero, right? Zero means paid. If you don't know what you write, none. It means is it that value is missing or not? Yes. Getting or not? Okay. So none type is used. None type is used to represent which values? None value. None value means no value. So which doesn't represent any value, right? That value you call it as which one? None value. None value means no value. None type is used to represent none values, right? For example, none is a keyword. None is a keyword, right? Is a keyword, and this keyword represent one value. How many keywords represent values? Three keywords. True, false, none. These three keywords represent what? Values. These three keywords represent values, right? For example, I'm saying roll number is one. Okay, roll number is one. Okay, suppose I don't know name. I don't know name of the student. Then what will I do? None. So is it name is known or unknown? Unknown. No value, right? Suppose if I print a roll number, I use print function. I print a name. What is roll number? One. What is a name? None. If I say type of roll number, what is the type of roll number? Integer. What is the type of name? None. What is the type of name? None type. Because it is holding which value? None value. It is holding none value. So what is the type of this? None type. If it is holding integer value, what is the type? Integer. Suppose if I'm writing fee, suppose I'm writing fee equal to some 4000 dot 0. What is the value of fee? For the what is the type of fee? Float. Roll number is integer, name is none, and fees is what? Float. Because this is holding which value? Float value. But name doesn't hold any value. Because of that, it is which type? None type. So in other languages, you call it as null. Null means with value or without value? Without value. Null value, none value. Okay. So none is a keyword here. None is a keyword which represent no value, right? So there is another d dot type is there. Okay, there is one. Yeah, you understood this none type, nothing more on this. None means no value. Okay, now how many ways can you represent integer is in how many formats? Four formats. What is that? Decimal, octal, hexadecimal, binary. This decimal, octal, hexadecimal, binary is called which system? Number system. So float is represented in how many formats? Two formats. One is fixed notation, exponential notation. What is the maximum number of decimal places allowed? 16. Getting or not? Okay. Yes. Then there is one more. There is one more d dot type is there. And what is it? Another d dot type? Boolean d dot type. So Boolean d dot type is there. Boolean d dot type. Boolean values are there. So Boolean d dot type is used to represent which values? Boolean values. Boolean values are logical values, and these values are represented using two keywords. Two keywords are there. One is true and one more is a false. These values are represented using two keywords. So one is a true and one more is what here? False. One is a true and one more is a false, right? Okay. Now these are two keywords are there. So these Boolean values are logical values. Logical. Suppose in this case, I said, for example, roll number is 1. Okay, I don't know name. There is a fees. There is a fees. Okay, there is a fee paid. Fee paid. I'm saying what? False. I said fee paid equal to what? False. That fee paid false. False indicates is it paid the fees or not paid? Not paid. So that I represent that as which value? Boolean value. That can be either true or false, right? Okay. Suppose type of roll number, type of name, type of what? Fee, and type of fee paid. Okay, fee paid, type of fee paid. So this is which type of class? Integer. This is none type. This is float. This is Boolean. And not only that, suppose when you are comparing two values, the result is in which one? Boolean. 10 is greater than 2. 10 is greater than 2. Yes. Yes. Yes, miss. Yes, miss. What here? True. What is the result of this expression? True. Which expression? Boolean expression. Suppose if I am saying 2 is greater than 10. No, right? No means what here? False. So the result of Boolean expressions, the result of the result of relational operator expression or Boolean expression or logical expression is what here? Boolean. So that can be true or false. So there is arithmetic expressions and there is a logical expressions or Boolean expressions. Arithmetic expression which consists of which operators? Arithmetic of 10 plus 20 plus 30. Result true or no? Result is what? Result is a true or result is a 60? Result is a 60. This is which expression? Arithmetic expression. Arithmetic, right? Suppose if I'm writing 10 greater than 2, is it this is arithmetic? No, this is what? Logical expression or Boolean expression, because the result of this is not integer. The result of this is what? Boolean. That returns either true or false. Getting or not? Okay, so these two keywords represents which value? Boolean value, right? Remember this. But T should be capital. Most of the students, when they are practicing, they'll write A equal to true. What will happen? Allowed or not allowed? So immediately it gives what? Error. So it is saying that name true is not defined. Did you mean what? True. Read this. Answer is there here only. Okay, answer is saying this is not true. This is what here? True. T should be what? Capital. Because true represent value. But true, is it represent value or? No. It doesn't represent the value. Right? Yes. These are called which data types? Standard data types. Okay, so standard data types reserves memory for how many values? One value. Integer data type reserves memory for one integer. Float data type reserves memory for one float. Complex data type reserves memory for one complex number. Boolean data type reserves memory for one Boolean. If you want to reserve memory for more than one, you have to go for collections. Please just try to practice this. Okay. Then tomorrow I'll tell you how to write a program with input and outputs. Okay, now yes. This standard data types you understood. Okay, all these four. How many standard data types are there? 5 or 6? 5 are there. Okay. Yes. You don't have more number of data types like C language. short by short, long, long, long. No, nothing is there. Only one integer, only one float. So we'll see tomorrow, right? So today we'll stop it here and tomorrow we'll continue this, right? Thank you. We'll see tomorrow, right? Positions. One is there at which position? Zero position.